Okay, so in this video, we are moving on to Chapter 6. Particularly, we're going to jump to 6.3. And so you can think of us from moving from equations. We are moving from equations to a different kind of statement. We're moving from equations to inequalities. Right, and so likely you've heard about what an inequality is, but hey, let's pretend that you haven't. So the question is, what is an inequality? So we're going to answer this in a sort of roundabout way. So to answer this question about what is an inequality, first we'll look at a more familiar object, and we'll look at the idea of what an equation is. So we'll look at the idea of an equation first before we jump to an inequality. We'll look at something maybe more familiar, and then extend that into something that you might be less familiar with. So an equation is simply a statement. That's all it is. A statement that involves symbols, right? So what does it say about those symbols or those mathematical objects? It's simply a statement that that states, using sort of the same word twice here, but you get the point. An equation is a statement that states that two mathematical objects are the same, right? It's not that they're anything else. They're just the same. They're the same thing. So two mathematical objects are the same. They're identical. They might be expressed differently, right? But they're really the same. So I'll give you an example. So here, I'll give you a sum, 2 plus 3. And this is really the same thing as, actually, I'm getting ahead of myself. 2 plus 3 is a sum. And then 1 plus 4, that is another sum. What can we say about these two objects, these two sums? Well, they're really identical, right? They're the same thing. This is 5 and this is 5, right? So to say or to state the sameness of these two objects, we relate them with this symbol, and that symbol is an equal sign. So that's what an equation is, and you know, obviously we can manipulate. This statement with some rules, right? We can manipulate this statement with the rules of algebra. That's that scary word algebra, but really what that means is if we wanted, we could play around with this statement, right? We could add 5 to both sides if we wanted, and if we do that, then this statement is still true, right? Let's say for some reason that we wanted to add 5 to the left-hand side. We're totally allowed to do that with the rules of algebra that state that you must add the same quantity to the right-hand side as well, and we'll talk more about this in a future video, although it's a very familiar rule by now. So that's what an equation is. An equation is a statement that states that two mathematical objects are the same. Now, and let's see if I can fix this. I seem to always be sort of pressing the wrong buttons here, but we'll just wait for me to get slowly better at technology. So that's what an equation is. So what is an inequality? Blah. What is an inequality? So an inequality, it's got some similarities to equations. An inequality is also a statement, right? An inequality, just like an equation, is a statement, but it states something different. So it states a different relationship, between two mathematical objects. So let me write out the full word here, just for clarity's sake. So an inequality is a statement that states a different relationship between two mathematical objects. And so what is this different relationship that exists? Well, we've probably seen them before, right? So let's say I have 3. This is a mathematical object. What kind of mathematical object is this? Well, it's a number. And this number has a specific size or value, right? So this is a mathematical object. And we know that we could come up with some other mathematical object like 2, right? This is also a number. Is there a relationship that exists between these two numbers? Well, if we drew an equal sign, that would be kind of silly, right? This would be very, very silly because it is a false statement, right? 3 is not the same thing as 2. They're not equal. Right? So one thing we could say is that 3 is not equal to 2, but I mean, that's not super informative. So what could we state is the relationship between 3 and 2? Well, we can say that 3 is larger than 2, or in mathematical vocabulary, we could say that 3 is greater than 2. Okay, so 3 is greater than 2. That is an equality. Sorry, that is not an this is not a statement of equality. This is a statement of inequality. There we go. So these two mathematical objects, they are not equal. They are unequal. I mean, that's kind of an awkward way to say it, but we can see here that this prefix in front of equality means not, right? These two objects are not equal. How exactly are these objects not equal? Well, one is greater than the other, right? That's exactly how they are not equal. That is the relationship that these two numbers have to each other. 3 is greater than 2. So for inequalities, instead of looking at the left side being equal, to the right-hand side of your statement, right? This is the left-hand side. This is the right-hand side. So instead of the left-hand side being equal to the right-hand side, in this particular case, the left-hand side is actually greater or larger than the right-hand side. So that's all we mean by an inequality. It's a fancy sounding word, inequality. What the heck is that? Well, it's simply a statement that says exactly how two mathematical objects are not equal to each other. In particular, this number is greater than. But we can have other kinds of statements of inequality. So we have a whole set of symbols, actually. We have a set of symbols that indicate different specific relationships or specific meanings or relationships. And these are important symbols to know, and I'll summarize them for you here. So I'm sure there is some sort of function in OneNote that allows me to make a nice grid. But let's just freehand this. So I'll have a set of symbols in this column. I'll have a set of meanings in this column. And I will have a set of examples of using each of those symbols in this column. So what is the first example here? Well, let's do the first symbol, a really familiar symbol here. This is an equal sign. So for this equal sign, it means equal to, right? The left-hand side is equal to. Equal to. What is an example? 2 plus 9 is equal to 6 plus 5. Right? So they are both equal to 11. So that's an equal sign. Now let's use this other kind of equal sign. This is not super informative because it doesn't tell us exactly how they're not equal, but it at least tells us that they aren't. So here is that other sign, and this really just means not equal to. It's just an equal sign with a cross through it. So what is an example of this? Well, let's say we have the number -5. We know that the number -5 is definitely not equal to the number 9, right? So that would be an example of using that symbol. Now let's look at another symbol. This is our first inequality symbol, our first true inequality symbol. I don't think this symbol is technically called an inequality symbol, but it definitely means not equal. But for this symbol right here, this means less than. And an example here would be, let's look at our numbers of 3 and 2. Let's write 2 first and 3 here. So here, this particular statement, 2 is less than 3, is how we would read that out loud. We can draw the reverse symbol. So it's actually the same symbol as this, the next symbol I'm going to draw. It's just got a reverse orientation, so it's just flipped. And if this means less than, what would this symbol mean? Well, it would mean greater than. And that was the first symbol that we used, right? Up here we have the example of 3 is greater than 2. Let's maybe do a different example here. Let's do pi is greater than 3. Right? 3.14159 forever is greater than 3. So there's a greater than symbol. But we can actually have slightly different versions of this symbol and this symbol, and I'll show you what they look like. These will be our last two symbols. So next up we have this symbol. And this means less than, right? It's got the same orientation. It's got the same orientation as this symbol. So this means less than or equal to. So less than or equal to. What would be an example here? Well, let's say we have the number 2. We know 2 is less than or equal to 2. This is true, right? 2. Although it's not less than, it is equal to, so this is technically a true statement. We could also have something like 2 and 3. 2 is less than or equal to 3. That is technically true, right? So 2 is less than 3, and so this satisfies that meaning of that symbol. You might initially think that it's kind of silly to have a less than and a less than or equal to. Why not just have a less than and then just use an equation to show equality? Well, it will actually be useful, and we'll see further examples of how it's useful. But for now, this is just what it means, and this is just kind of a silly example. Let's do the last symbol. We have a greater than sign right here, and we can also have a greater than or equal to. So greater than or equal to. And so what would be an example here? Well, we could say that pi is greater than or equal to 3. And we could also say that pi is greater than or equal to pi. Right? These are both technically true statements. Pi, although it's not equal to 3, it's greater than. Right? So that's technically true. That's technically true. I erased way more than I wanted to there. And so this is technically true. And then here, this next statement, pi is greater than or equal to pi. This is technically true because we have equality. Pi is equal to pi here. So to write greater than or equal to, you just write the greater than sign and then one horizontal bar underneath it. It's almost like you're taking one of the two horizontal bars of a typical equal sign and you're just placing it underneath the greater than sign. And then for less than or equal to, it's just the less than sign with one of those equals bars, horizontal equals bars underneath it. So there are the symbols, and in the next video we're going to be looking at how to apply these symbols to numbers on a number line graphs, and I will see you for that exciting video in a little bit.